All right, hello there. We're going to go over the review for assessment number 3 coming up soon. So looking at number 1, the graph of the function is shown. It's a parabola, a quadratic, right? What are the solutions and factors of this quadratic function? So this terminology here, solutions, notice those are the x-intercepts, and also those are called zeros. Those three words, there's also one more, the roots. Those three words basically mean the same thing, and the easiest thing is to look at the x-intercepts in the graph. So that would be -1 and also 2. Don't put parentheses around them. It's not a coordinate or anything, it's just two x values. All right, and the factors that go with that would be x plus 1, because remember the factors are opposite, and then x minus 2. And number 2, if you went from this quadratic function here, the basic parent function x squared, to this guy here, like what would happen, or what's going to change. So the negative causes a reflection. There is no stretch or shrink because there's nothing in front of the parentheses as a multiplier right there, so there's not anything to worry about. Then let's see, the -3, that's going to move you to the right 3, and then the +4 is going to move you up 4. Remember, you can't go right and left. You can't go up and down. It has to be one or the other. So that's what it is. All right, number 3. What are the zeros of this quadratic function? What are the factors? So this guy, we basically want to do like number 1. If it's crossed at -5, I would put x plus 5 as my factor. This one right here is a little bit more difficult, so let me go over to the side. This meant that when you solved the equation, you had x equals 2/3. So remember, this 3 used to be here. It used to be 3x equals 2. And that 2 used to be on the other side, so it used to be 3x minus 2. So this is the equation you solve to get 2/3. So 3x minus 2, if you need to do that. All right, number 4. So we're trying to plug in a -3 for all the x values. So make yourself like a little shell or whatever. You get 2 or a little plan. Something squared minus 3, something plus 5. So of course, all of your x's become -3. All right, so let's make sure we do our order of operations. For this part right here, I'm supposed to do -3 squared first. That'd be 9. So this becomes 2 times 9. So that becomes 18. All right, and then over here, a minus times a minus is a +9, and then +5. So my final answer for that would be 32. No, wait. 18 and 9 is 27. Yeah, 32. That is g of -3. All right, this guy here, number 5, factor completely. So the first thing you should always check is for a GCF. Remember, GCF means greatest common factor. And these do have an x in common, and let's see, they all divide by 2 as well. So 2 is their greatest factor they have in common, and an x. So let's see, that leaves us with 2x squared minus 3x minus 14. And if it helps you, you can write a little 2x under here to remember that you're dividing by 2x. Okay, so let's check again if that factors any more. The GCF is 2x, and let's see if that factors any more. So 2x and x, 14. Let me try 7 and 2. So I can't put the 2 here, so I have to put the 7 here and 2 there. So let's check it out. The outside is giving me a 4x, the inside is giving me a 7x. So that can be a -3 if I do +4 minus 7. And then -7 times 2 is -14. So yep, that's our final factoring answer. All right, number 6. Maya was using the quadratic formula to solve a quadratic function or quadratic equation on her homework. When she found the value of the discriminant was -20. So basically, remember the discriminant, your quadratic formula is -b plus or minus square root b squared minus 4ac all over 2a. The discriminant is this piece right here, not the radical part, but the stuff inside the radical. So b squared minus 4ac was negative. So -20, that means it's going to be imaginary solutions. That means that, like if it were this problem here, you wouldn't see any x-intercepts. The graph would have to be above the x-axis, or maybe it's upside down and it's below, but it's never going to touch the x-axis. All right. So that means nope. There are no real solutions. That's true because they're imaginary or complex. 1, no. The graph will have 2 x-intercepts. Nope, because it's not going to touch the x-axis. So not a double root, not one x-intercept, no x-intercepts. Okay, so always two facts the discriminant tells you. All right, number 7, solve by square roots. So this is very simple to solve by square roots because I only have x squared there. So I'm going to take away 30. So my goal is to get the x squared alone. So it's going to be 4x squared equals, let me see, negative 24. Now you can't take the square root yet. You have to get rid of the 4. So divide both sides by 4 and I get negative 6. So now I'm ready to apply my square root. And my answer is plus or minus radical negative 6. But I don't know the square root of 6, but that negative inside needs to come out. So it's plus or minus I radical 6. All right, number 8, determine the discriminant. So remember the discriminant is just this value, b squared minus 4ac. So my a is here, my b is there, my c is there. So negative 3 is my b, so it would be 9 because I square it, minus 4. A is 2, c is negative 8. All right, so you type that into Desmos or just work it out. Let's see, you get 9. 2 negatives is a positive. 4 times 2 is 8, so I have 8 times 8, 64. So 9 plus 64 is 73. So 73. So this tells me that I'm going to have 2 real solutions because the part inside the radical, like right there, is going to be a positive number. They're going to be gross and they're going to be decimals, but there are going to be 2 real solutions. They're not going to be imaginary or complex. All right, moving on. We're going to solve this, and it doesn't say how. But I do notice, oh, look at this, that I have an x squared here, an x squared there, and there's nothing else going on. So I think the easiest thing to do would be to solve by square roots, which means I need to take away 2x squared here. So I have 9x squared minus 18 equals 7. Then I'm going to add 18 over here. So I separate. I get 9x squared equals, let's see, 25. Remember, I got to divide by 9. Now 25 doesn't divide by 9, so I'm just going to put 25 over 9. So now I'm ready to do the square root of both sides. So that means that x is plus or minus, and I know the square root of 25 and 9, so that's 5 over 3. So plus or minus 5/3. So this came out so pretty, so I could have also done this by factoring. If you move everything, instead of separating everything, if you just move everything over to the left to have it together, look what I would have gotten. I would have had, let me use a different color. I would have had 9x squared still, but if I moved the 7 over, I would have had minus 25 equals 0. And then I could easily factor that. It'd be 3x and 3x plus 5 and minus 5. So you see my answers are still negative 5/3 and positive 5/3. So you could have done that as well. Whatever you find easier. But sometimes the factoring doesn't work, so it's actually safest to do it by square roots if you notice there's only x squareds. All right, this one says solve by factoring. So I'm going to get everything together, take away 6x squared. So I have x squared minus 10x. This is gone, and the negative 25 just needs to come over. So why don't we say plus 25 then? All right, so 5 and 5 multiply to 25 and add up to 10. So it would be x minus 5, x minus 5. So the solution is just 5. It's a double root. All right, number 11, difference of 2 squares. So x and x, one of them is plus 10, one of them is minus 10. Because remember, this part makes negative 10x, this part makes positive 10x. They cancel, and then it still makes negative 100 on the end. All right, number 12, factoring. So there's no GCF, so I'm just going to go right to my 2 parentheses, 3x and x. Only thing that makes 5 is 5 and 1. And I think I'm going to put the 5 out here and the 1 there because I noticed in my mind that this is going to be 15, which is close to 14, and there's a 1x there. So if I do positive 15 minus 1, it gets me 14, and my negative 1 times 5 still makes negative 5. So there's my answer. All right, solved by the quadratic formula. I'm going to have to take my 2x squared away over here. So that gives me 3x squared minus 4x plus 6 equals 0 to solve. And so then I can see my a, my b, and my c. It's always safest to write down what a, b, and c are so that your teacher can tell if you're using like the wrong sign and that's what happened, and just get a little bit off. But so my a is 3, my b is negative 4, and my c is 6, just to write them down somewhere. Now it's asking for d, the discriminant. So let's figure out b squared minus 4ac. That's the worst part. So b squared, so it would be 16 minus 4 times 3 times 6. So you put that in Desmos, or you just work it out. And let's see. 24 times 3, 60, 72. So I got 16 minus 72 here. Or again, you type that whole thing into Desmos and you can get it. So 16 minus 72 is going to be a negative, and so it'll be 62, 60, and 4 more, 56. All right, so now 56, let me check out 56 for a second and see if it breaks down. It goes 2, and then, let's see, 2 goes into there, so that makes 24. No, that's not right. Sorry. 56 is 2 times 28. Yes, and 28 is 4 times 7, and 4 is 2 times 2. So I can break down 56 later on. So I'm going to notice that I can break down 56, I can bring out a pair of 2's, and then I'll have a 2 and a 7 left inside. Just planning ahead. All right. So let's see. Start my quadratic formula. Negative b, so a negative of a negative 4 is a positive 4, plus or minus the square root. I already have this worked out. It's a negative 56 in here. And the bottom is 2 times a, so 2 times 3 is 6. All right, so let's clean that up. So I got 4 plus or minus. We already learned that square root of 56 was 2 radical 14. So I have the 2 coming out, and then the 7 and the 2 staying in. So 2i radical 14. So notice that I is there because it was a negative 56 all over 6. And now, one last thing. These 3 numbers all divide by 2. So I'm going to get 2 plus or minus 1i radical 14 all over 3. So there's my answers. 2 plus or minus I radical 14 over 3. That's 2 answers. Alrighty. So this last problem, we're going to graph this, and we're going to go ahead and label the vertex and the arrows. So remember that this thing moves to the left 3, and it goes down 7. So left 3 down 7 puts me right there. Alrighty, so parabolas. Parabolas, when you graph them, they have this pattern. Right at the center, they go over 1, up 1 here, so 1, 1, then they go out 2, and they go up 4, right, because 2 squared is 4. Same thing on the other side, and out 3 and up 9, because 3 squared is 9. So this is the pattern that they follow to make that shape. So I'm going to do that a little bit here. Over 1 and up 1, because 1 squared is 1. Oopsie. Over 2 and up 4. There. All right, or, you can always just graph it on Desmos as well. Let's see, once I have 1, I can just copy it. And then over 3 and up 9. 1, 2, 3, and up 9. So this will be right there. All right, so I can get a pretty nice picture going right there. All right, my drawing's so bad, but my y-intercept is right there at 2. All right, so my domain means what can I use in this problem? Well, my width. My domain is all real numbers, because this point right here is negative 3, negative 7. This one over here is on the right, and it's going up. And this guy over here is left, and it's going up. So my domain is all real numbers, negative infinity to infinity. My range. The lowest this goes is negative 7. So it goes from negative 7 to infinity. Interval of increase. So if I look at this picture, the whole right side is increasing. So this whole area over here on the right is all increasing. So that area, that yellow section, begins at the number negative 3. So from negative 3 to infinity. And then before negative 3 is decreasing. So from negative infinity to negative 3. Because we're breaking up our x-axis. So what we're doing is we're saying this is negative 3, it goes off to infinity, and this part's negative infinity. So that's how I got those two answers. All right, my end behavior. Both ends of the graph are going up, so they're both going to positive infinity, my y values. All right, describe the transformation. So we kind of already did that, but it went left 3 and down 7. Alrighty, last problem. So we're gonna label some points on here. Let's see, the vertex is negative 2, 4. Then over here on the right, I have positive infinity and negative infinity going down. Then on the left, it's on the left, so it's negative infinity, and it's going down negative infinity as well. All right, my domain. Again, all real numbers. You can write this double R, or you could say negative infinity to infinity. Then for the range, it's going down forever, but it's not going higher than 4. So negative infinity to 4, because 4 is the highest. Increasing. So the increasing side here, this time the left side is increasing. So if I go ahead and name that area, so it's stopping at negative 2, and it's coming from negative infinity, and it's going to positive infinity over here. So the increase area is the yellow part. That's from negative infinity to negative 2. The decrease area is from negative 2 on, so negative 2 to infinity. And x-intercepts, all right, negative 4. And also 0. Y-intercept, oh, whoops, it's asked for ordered pairs. So let me go and erase that. So negative 4, 0, and 0, 0. The y-intercept is at 0, 0 also. My end behavior, both going down, so negative infinity. And write the equation. All right, so notice here the little pattern that I told you about before. Look at what's happening. Here's my vertex. It's going out 1 and down over 1. Okay, and then it's going over 2 and then 4 spaces, over 2 and 4. So it's following that pattern of going out 1, out 1, down 4. Out. If I checked out 3, it would be down 9, like right here and right here. Okay, so there's no stretch or shrink, is my point. So let's see what happened to this thing. It got moved left 2, up 4, and a reflection. So that's what I have to do. So left 2, so put a negative for my reflection. Left 2 is plus 2, and then up 4 is plus 4. My solutions are also my x-intercepts for letter I, so it'd be negative 4 and 0. All right, that's it.